remainder theorem. Now let's see what this is all about. So what we have is we have a few statements with us which we need to analyze. So the statements are x when divided by 4 leaves a remainder of 2, y when divided by 4 leaves a remainder of 1. And then there are 4 questions. For example, x plus y divided by 4, we have to find the remainder. X minus y divided by 4, we have to find the remainder. And x into y divided by 4, we have to find the remainder. And y minus x divided by 4, we have to find the remainder. Now what happens is that for this entire topic, there is just one single theme that you are going to remember, even for question solving, even for now, which is going to make your life a much simpler. Now the theme or the statement, the only one statement that you are going to remember and apply throughout this remainder theorem idea is that replace the number by remainder. Listen to this very carefully. You are going to do replace the number by remainder straight away. Simple as that. For example, if I apply that, the first statement, x when divided by 4 leaves a remainder of 2. My number is x. I just said that we need to replace the number by remainder. So I'm going to replace x by 2. Similarly, y when divided by 4 leaves a remainder of 1. I'm going to replace y by 1. That's it. That is the only thing that you are going to do. And let's see what happens then very quickly. So the first question, x plus y divided by 4, याने for us x is 2, y is 1, x plus y becomes 2 plus 1, 2 plus 1 becomes 3, 3 when you divide by 4, I hope you will realize that you can't divide, you will get the remainder as 3 itself. Similarly, second question, x minus y, याने 2 minus 1 is 1, 1 when divided by 4 will give you the remainder as 1 itself. Third one, x into y, which is 2 into 1, which is 2. 2 when divided by 4 will give you the remainder as 2 itself. And the fourth one, y minus x, which is 1 minus 2, which is minus 1, which is divided by 4, will give you the remainder as minus 1. Now I know you must be a little bit surprised that what is this negative remainder and all of that. Don't be afraid right now. We are soon going to understand what that exactly means also. But so far right now, based on the valuation, just take it like that. Minus 1 when divided by 4, you get the remainder as minus 1 itself. So the central theme of this topic is, this is the one, replace the number by remainder. Exact same thing you are going to use in the questions as well. And now going back to the same query, which is the idea of negative remainder. So let's explore that in detail. So what we have is, on the number line, we have written some numbers 4, 5, 6, 7, 8, 9, and all the numbers, because we were dividing by 4 in the questions that we were discussing right now. Let's try and represent all these numbers as a multiple of 4. And what we will do is we'll go from left to right as well as right to left. So when we go like that from left to right, what we have is 4 is some multiple of 4, which is 4k. 5 can be written as multiple of 4 plus 1, yani 4k plus 1. 6 can be written as multiple of 4 plus 2, yani 4k plus 2. 7 can be written as multiple of 4 plus 3, yani 4k plus 3. And 8 is a altogether different multiple of 4. Going behind from right to left, we have 8 as another multiple of 4, which is 4m apparently. 7, if we are wanting to write in terms of 8, we get multiple of 4 minus 1, yani 4m minus 1. 6 we get it as 4m minus 2. 5 we get it as 4m minus 3. And 4 we get it as 4k as a multiple of 4 itself. Now what happens is, suppose if I pick one number out of these, suppose if I pick 7, but for that 7 number, I have two generic forms available. One of them is multiple of 4 plus 3 and one of them is multiple of 4 minus 1. So if I consider 4k plus 3 and if I divide that by 4, obviously I'll be getting the remainder as positive 3. But if I pick the another form for the same number, which is multiple of 4 minus 1, and if I divide that number by 4, 4m minus 1 divided by 4, what I'll get is remainder as minus 1. So I think it becomes very evident and clear from this particular scenario is that negative number is nothing new as such. It is just another way of representing positive remainder only. And for every positive remainder, there is going to be an equivalent negative remainder. For example, another example, if we pick 6, one of the generic types, if we divide by 4, we will get the remainder as plus 2. And the other type will get the remainder as minus 2. For 5, one of the generic type when divided by 4 will give us the remainder as plus 1, and the other generic type will give us the remainder as minus 3. So both positive and negative remainders are part of each other. They are related to each other. It is nothing new, nothing fancy as such. You don't have to be scared at all going forward for this. All you are going to do is if you get a negative remainder, try and figure out the positive remainder, the equivalent positive remainder. So that's the idea of negative remainders. Now, whatever the theory that we have learned, let's try and apply that in terms of solving the questions on remainder theorem. So this is a question that we have: x when divided by 15 leaves a remainder of 2. And as usual, if you remember the central idea, replace the number by remainder. So we are going to replace x by 2, straight as that. And then we have 4 questions as usual. First question, x square when divided by 15. Yani x square becomes 2 square is 4. 4 when divided by 15 gives you remainder as plus 4. Next is x cube, which is 2 cube when divided by 15 will give you the remainder as 8. Next is 2 raised to 4, which is 16. 16 when divided by 15 will give you the remainder as plus 1. And the fourth one is the type of questions mostly that you will see, which is x raised to 86. In this case, it will become 2 raised to 86. So 2 raised to 86 divided by 15, what is the remainder? And this is where it becomes interesting, because now going forward, what we are going to do is, again listen to this very carefully, is that which power of the given number which when divided by the given divisor will give you the remainder either as positive 1 or negative 1. In simpler words, in this particular question, we are going to figure out which power of 2 when divided by 15 will give us the remainder either plus 1 or minus 1. Both will work. And if you observe, just now in the third question we had seen that x raised to 4 yani 2 raised to 4 divided by 15 gave us the remainder as positive 1. And that is why what we are doing is also that this 86 we are trying to split it as multiple of 4. So obviously 86 is not a multiple of 4. The nearest number to that which is multiple of 4 is 84. And that is why the adjustment that you can see. So 2 raised to 86 can be further written as 2 raised to 4 the whole raised to 21, because then it becomes 2 raised to 84 into 2 raised to 2. Laws of indices from the topic surds and indices, which is D1. The whole thing divided by 15. Now, when we start dividing, obviously 2 raised to 4 is 16. 16 when divided by 15 gives us remainder plus 1. And the right side is 2 raised to 2, which is 4 divided by 15 will give us the remainder 4 only. And if you remember the idea again, replace the number by remainder. We'll replace 16 by 17. And then my question becomes 1 raised to 21 divided by 15. 1 raised to anything becomes 1. 1 divided by 15 gives me a remainder plus 1 only on the left side. On the right side, I have 4. 4 when divided by 15 gives me a remainder as 4 itself. Beach mein we have multiplication 1 into 4. We get the answer as 4 as the final remainder. So this is how the simplification will work. The only thing that you are going to require is which power of given number when divided by the given divisor will give you the remainder either as plus 1 or minus 1. That's the only thing you are going to figure it out, and then after that you need to do the mathematical simplification. The next one after this is another question wherein which we have x when divided by 80 leaves a remainder of 77. Now I know that we need to replace the number by remainder, but we can't replace x by 77. That will be too tedious to handle, because 77 square, cube, raised to 4 and all of that will be a mess. But instead here, what you should ideally do is you can use the idea of negative remainder. So divided by 80, you get a remainder of positive remainder of 77. Obviously, you will also get a negative remainder of minus 3. And that is also a remainder, whether it is 77 or minus 3, irrelevant. And now because of this important idea, what else that you can do is, instead of replacing x by 77, which is huge for us for simplification, we can replace x by minus 3, which is also the remainder. So remember folks, whenever the positive remainder is very huge, think of a negative remainder which will be equally less, which will be easy for you to handle the calculation. So x becomes minus 3, all the questions will change straight away. X square यानी minus 3 का square is 9. 9 when divided by 80 gives you the remainder as 9 itself. X cube यानी minus 3 का cube is minus 27, which when divided by 80 will give you the remainder as minus 27 or positive 53. How do we get that? 80 minus 27 gives us positive 53. X raised to 4 minus 3 raised to 4 is positive 81. 81 divided by 80, we get the remainder as plus 1. Fourth one, x raised to 86, as usual, minus 3 raised to 86. Same idea, which power of minus 3 when divided by 80 will give us the remainder as plus 1 or minus 1. And again, just now we had seen in the third question that minus 3 ka fourth power when divided by 80 gives us the remainder as plus 1. So same thing we are also going to apply here as well. Minus 3 ka fourth power divided by 80 will give us the remainder plus 1. But here 86 again is not a multiple of 4. The nearest number is again 84, and hence the adjustments, laws of indices. So minus 3 raised to 86 can be further simplified as minus 3 raised to 4 the whole raised to 21 into minus 3 ka square divided by 80. As usual, minus 3 raised to 4 is 81. 81 divided by 80, you get the remainder as 1. Minus 3 ka square on the right side is 9. Positive 9 divided by 80 will give you remainder 9. As usual, same idea, replace the number by remainder. So 81 के जगह पे we are going to replace 1. 1 raised to anything becomes 1. 1 divided by 80 gives you remainder 1 only. Right side में you get the remainder 9. In between there is a multiplication. 1 into 9, you get the answer as 9. The final answer as 9. So once you understand which power will give you the remainder plus 1 or minus 1, you easily can simplify the type of questions, no matter how complicated they seem to be. So these are the workings that are necessary to tackle this topic. Now one last part before we wrap this up is finding the remainders for non-coprime numbers, as in 5 when divided by 3 you get remainder 2. 50 when divided by 30 you get remainder 20. 5000 divided by 3000 you get the remainder as 2000. So combining all these three conclusions, what we can say that in a generic form is that a upon b, I mean if you divide a by b you get the remainder as r. So if you do ax upon bx, obviously the remainder will be rx. The same multiplying factor with which you are multiplying the original numbers a and b, the same multiplying factor will be used to figure out the remainder, r ke jagah pe rx. So let's begin. The first one, typical bread and butter question. Find the remainder when 3 raised to 38 is divided by 244. So we'll need to figure out which power of 3 when divided by 244 will give us the remainder plus 1 or minus 1. So it is the fifth power, which gives you 243, and 243 when divided by 244 will give you a remainder of minus 1. So we need to break 38 as a multiple of 5, but it is not the case. So the nearest number of 38, which is multiple of 5, is 35. So let's do the adjustment. 3 raised to 38 can be broken as 3 raised to 5 the whole raised to 7, which is 3 raised to 35. and the remaining 3 raised to 3 besides that. 3 raised to 5 divided by 244, remainder is minus 1. Replace the number by remainder, you get minus 1 as the answer. Right side, 3 cube, which is 27. 27 divided by 244, you get the remainder 27. In between, there is multiplication, minus 1 into 27. So the final answer is remainder is either minus 27 or the positive remainder will be 244 minus 27. That will give you 217 as the answer. So people usually make the mistake, they get minus 27 and they will mark probably none of these, which is not the case. Whenever you get the negative remainder, I would always suggest to find out positive remainder so that you get the correct answer. If that is also not there, then you mark none of these. That is fine. But without checking first the positive remainder, please don't mark none of these in all these types of questions. Second one, scary looking question. Find the remainder when 38 raised to 16 factorial raised to 1777 is divided by 70. So let's first get rid of the scary power. Let that be m. So now your question is little better looking at least. 38 raised to m divided by 17. What is the remainder? So whenever numerator is bigger than the denominator, always divide the numerator by denominator and you will get 38 divided by 17. Replace the number by remainder. You get 4 as the answer. So now your question changes to 4 raised to m divided by 17. And now that it has converted to R type, we will try to figure out that which power of 4 when divided by 17 will give you a remainder plus or minus 1. So it is 4 square, which is 16, when divided by 17 will give you remainder minus 1. So 4 square, for that adjustment, we will have to write m as m by 2. So 4 square, the whole raised to m by 2 divided by 17. Replace the number by remainder, you get minus 1 raised to m by 2, the whole thing divided by 17. What is the answer? So now only thing for us to figure out is whether this m by 2 is even or odd. Because if this m by 2 is odd, then minus 1 raised to odd will be minus 1, and minus 1 divided by 17, the remainder will also be minus 1. But if this m by 2 is even, then minus 1 raised to even will be even, and I mean minus 1 raised to even will be plus 1, and plus 1 divided by 17, the answer will be plus 1. So if you remember, m was 16 factorial raised to 1777, but we had m by 2 and that whole thing divided by 2, and that is a huge even number. That means now our question is minus 1 raised to even power, which is plus 1, and plus 1 divided by 17. The final answer is plus 1. Option first. Third one, similar background. Get rid of the scary power first, which is m. So question becomes 12369, the whole raised to m divided by 15. What is the remainder? Same funda again. Numerator is bigger than the denominator. Divide the numerator by denominator. Replace the number by remainder. So when you divide 12369 divided by 15, you get the remainder as 9. So your question becomes 9 raised to m divided by 15. What is the remainder? Now whatever we are going to do is called as pattern finding. Now for this pattern finding, let's consider a few examples. So let's suppose 9 raised to 1, which is 9. When you divide that by 15, you will get the remainder 9. 9 square, 81. 81 divided by 15, remainder will be plus 6. 9 cube, 729 divided by 15, the remainder will be 9. And 9 raised to 4 divided by 15, it will not require rocket science for you to figure out the pattern that the remainder has to be 6. So what you end up observing here is that 9 raised to a odd power when divided by 15 will always give you a remainder of plus 9. But 9 raised to a even power when divided by 15 will always give you a remainder of plus 6. So again here for you to only figure out in our question whether this m is odd or
even. And if you remember, this m was what? 1 square plus 2 square plus 3 square, so on till 53 square. And to decide whether it is even or odd, we'll need the formula that we have done in C3 operation on numbers, that is sum of the first n squares. So the formula was the biggest formula, n into n plus 1 into 2n plus 1 upon 6. When you apply that, what you end up realizing is the number is odd. You don't need the calculation, or don't find out the actual value. Be smart and reduce the time taken for that calculation. That is odd. That means 9 raised to odd divided by 15. The remainder is 9. That means the answer of this question is also 9, which is option 2. Fourth one. It's a brilliant question because two times we are going to use remainder theorem and last digit and cyclicity as well here, because in between it turns out to be a different question inside the solution of this main question. You have to find out the remainder when 3 raised to 5 raised to 6 raised to 7 raised to 8 raised to 9 raised to 10. The whole thing is divided by 5. So again, first of all, find out the pattern. 3 raised to 1 divided by 5. Remainder is 3. 3 square, that is 9, divided by 5. Remainder is plus 4. 3 cube 27 divided by 5. Remainder is 2. And 3 raised to 4 81 divided by 5. The remainder is plus 1. And 3 raised to 5, that is 243 divided by 5. The remainder is plus 3 again. So what you will observe is that the remainder 3 will repeat after 4 powers. That means the cyclicity of remainder when a power of 3 is divided by 5 is 4. And that is what we are going to do here as well. So now this is going to get converted to a separate question in between altogether. That if you remember, for finding out this answer, what we used to do, that we have covered in the previous class only, divide the big power by the cyclicity of the last digit. So last digit is 3 and 3 ka cyclicity is 4. So divide the power by 4, and hence if you remember, this question now gets converted to a different question of remainder theorem altogether. So now the question is 5 raised to 6 raised to 7 raised to 8 raised to 9 raised to 10. The whole thing is divided by power divided by cyclicity of the last digit, which is 4. To simplify this, what we will do is, again, let the big power be m. Then question is 5 raised to m divided by 4. 5 raised to m, 5 divided by 4, because numerator is bigger than denominator, you get the remainder 1. So the question becomes, I mean, after replacing the number by remainder, the question becomes 1 raised to m divided by 4. 1 raised to anything divided by 4, the answer is 1 only. And that means this last part, the only simplification of power, 5 raised to 6 raised to 7 raised to 8 raised to 9 raised to 10, that answer is 1. That means the question is 3 raised to 1 divided by 5, and 3 raised to 1 divided by 5, the remainder is 3. So don't consider their answer. They have considered the answer as 1, which they were figuring out as this answer. But if you remember, the original question was not this. The original question was this. The one answer is only for the power. So the final question will be 3 raised to 1 divided by 5. 3 raised to 1 divided by 5, we know the remainder is 3. To make a correction here, don't take their answer, which is 1. They have incorrectly marked that. Answer is 3, and you need to mark the option accordingly. It is not option 3, answer is 3 for the question. Fifth one, find the remainders when these numbers are divided by 58. So here we'll have to do a cube plus b cube. But while making the groups, make the groups as these ones. So make the first and the last one together and the middle two together. Why so? Because when you apply a cube plus b cube, the first bracket of that is a plus b. And a plus b will be 13 plus 16, which is 29. And 14 plus 15 again, 29. So you can take that 29 common. That's the only reason to make such groups. So when you apply a cube plus b cube, you get a plus b in the first bracket. in the second bracket a square minus ab plus b square. Same thing will be done for the middle two. A plus b in the first bracket, which is 14 plus 15, and in the second bracket a cube, sorry, a square minus ab plus b square. Now after this, what you can do is take 29 common and don't find out any of the values by doing the calculation, but find out the nature of the values. So for example, 13 square 169, which is odd. 13 into 16, which will be an even number. 16 square 256, which is even again. 14 square 196, even again. 14 into 15, even. 15 square 225, even. Sorry, it will be odd. Now when you further simplify the first bracket, odd minus even will be odd, and odd plus even, the final conclusion of the first bracket will be odd. Similarly for the second bracket, even minus even will be even, and even plus odd will be odd. And in between there is a plus sign, so odd plus odd, which will be even. So what are we doing is this entire expression gets converted to 29 into a even number, and which was supposed to be divided by 58. If you remember, 29 twos is 58. That means whenever you multiply 29 with an even number, that is by default going to be a multiple of 58. And when a multiple of 58 is divided by 58, obviously the answer will be, the remainder will be 0. So answer of this question is option 1, which is 0. Sixth one, find the remainder when these numbers are divided by 29. Now here the idea is convert the powers into a same power. So 444 and 333, the common number you can convert the power to is 111. So that means from the first number we'll have to take 4 common. So your question becomes 3 raised to 4, the whole raised to 111. And for the second number, it becomes 4 cube, the whole raised to 111. Now why we did this? Because now when you look at this, it is a question of a raised to n plus b raised to n when n is odd. Again from C3 operation on number, if you use divisibility of algebraic expressions, what you will get is a raised to n plus b raised to n when n is odd, that is of the type a cube plus b cube, and a cube plus b cube is always divisible by a plus b. A plus b will be the factor. So that means this entire expression will be a factor of 3 raised to 4 plus 4 raised to 3. And 3 raised to 4 is 81. 4 raised to 3 is 64. 81 plus 64, 145. And this entire number, which is a multiple of 145, is supposed to be divided by 29. And obviously 145 itself is 29 5s. Yani 145 itself is a multiple of 29. So any multiple of 145, which when divided by 25, will be perfectly divisible always. And that means again in this case, the remainder will be 0. Seventh one, find the remainder when 6 raised to 2013 is divided by 222. Now, here we are going to learn a very important idea that to make the adjustments, sometimes you can cancel some common multiple from both numerator and denominator. So we can cancel 6 from both numerator and denominator. So our question becomes 6 raised to 2012 upon 37. Now, this becomes one of our types. Which power of 6 when divided by 37 will give us the remainder plus 1 or minus 1? So it is 6 square, which is 36. So 6 square 36. So break down 2012 as a multiple of 2, which is the case. So our question becomes 6 square, the whole raised to 1006 divided by 37. Now 6 square is 36. 36 divided by 37. Remainder is minus 1. So question becomes replace the number by remainder. It becomes minus 1 raised to 1006 divided by even power. Minus 1 raised to a even power. What you get is plus 1 as the answer. And 1 when divided by 37, you will get the remainder as plus 1. But hold on, don't mark that answer because that answer is for the first question 6 raised to 2012 upon 37. We were not supposed to find that. We were supposed to find for the earlier question from which we cancelled out 6 from both numerator and denominator. So to find out the original answer, whatever we have cancelled earlier as a common multiple, we'll need to subtract, we'll need to multiply with that. So 1 into 6, that is going to give us the answer as plus 6. So the property that we are learning here is sometimes for any of the adjustments, if you do this, that cancel out a common multiple from both numerator and denominator, make sure whenever you get the final answer, make sure you multiply back with that multiple that you had cancelled earlier. So that was the learning from this question. Eighth one, last two digits of 2 raised to 100. I'll give you a property for this. Remember this. Last two digits of any number is as good as dividing that number by 100. So this is the thought process you will need to work with. So 2 raised to 100 divide by 100. That will give me last two digits of 2 raised to 100. For any number ka last two digits always divide by 100. For any number ka last three digits always divide by 1000. So this is something that you should try now that we have solving 7-8 questions of remainder theorem. You should at least give it a try. It's a great question. What I'll do is I'll discuss an entirely different thought process, which is sometimes very difficult to strike in the exam in terms of shortcut. So what you can do is 2 raised to 100 can be written as 2 raised to 10 the whole raised to 10. You can see on the right side. 2 raised to 10 is 1024. So question becomes 1024 raised to 10k last two digits. So last two digits are 24. Let's find out the pattern. 24 raised to 1, last two digits 24. 24 square 576, last two digits 76. 24 cube, last two digits will again be 24. So what you realize is that 24 raised to a odd power, the last two digits are always 24, and 24 raised to an even power, the last two digits are always 76. And when you look at this question, 1024 raised to 10, obviously the power is an even power. So that means the last two digits will be 76. So that is the shortcut that you can remember. But again, think from the perspective of the original approach, which is the actual question of remainder theorem. You can see the solution also, but you give it a try to see whether can you get this by trying that approach. Ninth one, again going to tell us a new property. Find the remainder when 6 raised to 152 is divided by 1 is divided by 30. So the property is a raised to p minus 1 upon p, where a and p are co-prime and a is less than p. If these restrictions are satisfied, then the remainder for this expression is 1. Now, how do we first of all understand that? So if you observe our question, p is 31. That means p minus 1 should be 30. Yani 152 ko we have to write it as a multiple of 30, which is not the case. But the nearest number of 152, which is a multiple of 30, is 150. And that is where the adjustment comes into the picture. So the power 152 can be adjusted as 6 raised to 30, the whole raised to 5, into 6 raised to 2, laws of indices purely, the whole thing divided by 31. And now you will see 6 raised to 30 upon 31 is of this type, a raised to p minus 1 upon p, where 6 and 31, a and p are co-prime, and a is less than P. So the answer for that remainder is 1. So left side, your remainder is 1. Right side, you still have 6 square, which is 36. 36 when divided by 31, the remainder will be 5. In between, there is a multiplication. Left side remainder 1, right side remainder 5. 1 into 5. Final answer 5. Option 3. Improper. All these are purely observational skills and the structures. Last one. Find the remainder when 1 factorial plus 2 factorial plus 3 factorial so on till 100 factorial is divided by the product of first 7 natural numbers. Yani divided by 1 into 2 into 3 into 4 into 5 into 6 into 7. These are the first 7 natural numbers, which is as good as 7 factorial. So when you divide this number by 7 factorial, till 7 factorial, everything is fine. And from 8 factorial onwards, I mean 8 factorial, you can write it as 8 into 7 factorial. 9 factorial, you can write it as 9 into 8 into 7 factorial, and so on. So every number from 8 factorial onwards can be written as a multiple of 7 factorial, including 100 factorial itself. So what does that tells us is that from 7 factorial onwards, every number can be written as a multiple of 7 factorial. So you can take 7 factorial common out from those numbers. And when you divide that entire thing by 7 factorial, which is a multiple of 7 factorial, obviously the remainder for that case will be 0. So you need to only calculate the remainder for 1 factorial plus 2 factorial plus 3 factorial, so on till 6 factorial. So 1 factorial is 1, 2 factorial is 2, 3 factorial is 3 into 2 into 1, which is 6. 4 factorial is 24. In a similar manner, 5 factorial is 120. 6 factorial is 720. When you add all of that, it is 873. 873 when divided by 7 factorial will give you the remainder as 873 only. So right side remainder 0 because all are multiples of 7 factorial. When divided by 7 factorial, completely divisible, remainder 0. Left side 1 factorial से लेके 6 factorial, sum is 873 divided by 7 factorial, remainder is 873. So the final remainder 873, option 4. So folks, what are the learnings from this extremely out of box thought process chapter? Lot of solvings are involved, and there are a lot of different innovative ideas and new ideas that you need to think of when it comes to remainder theorem, and hence you need to be very careful with that. So with this, we are done with remainder theorem, and we are also done with entire D module, which comes under the number system bracket. So chapter C and D comes under number system. So make sure you revise all of that. If you have any questions, let us know. Thank you so much.